Hello, welcome. Continuation of the tutorial on trigonometry. I know you have watched at least 20 of those episodes. We are in episode number 25. Here we want to take a discussion on the compound angles, which is the sum and difference of two angles measure. We are going to see how we develop such formulas, beginning with the cosine of that. We now cosine, the sine, and the tangent. So we pick it one after the other. So let's consider these two unit circles. In the beginning of the episode, we talk about what a unit circle is, the one that have the radius being what, 1 unit. So this is just 1 unit. So movement of an angles are in the anti-clockwise direction. So if I move from the x-axis, which is 0 here, to where the f is, that angles that are this line is showing the angle beta. And that place, wherever the point is on the circle, have x coordinate and y coordinate is a point. So we can indicate here as, remember what we did in the first two episodes, the correspondent on the x-axis is the cos value, then on the axis is the sine value. So this is going to be a point on x, which is the cos of the angle. So here, as you have, let me write this here, the cos of the angle beta, then the sine of the angle beta. This is the point at where f is located. The x, comma, y. But what is the x? The x is the cos of the angle that we are having, the terminal line. All right. Then when I move from here all the way to f, I am forming the angle beta. But when I move from here all the way to d, I'm forming the angle alpha. From here all the way to here. So our terminal line become OD. Then the point here also have an x coordinate, which is also going to be the cos of this particular angle we are having here, which I can have the d as the cos of the angle alpha, the sine of the angle alpha. That is the point. So this is also f, the point f there. All right. So what we are having here is that the angle difference from OF and OD, the angle difference is the angle here we have is bigger, alpha. Alpha is bigger than beta. So alpha minus beta give us the angle between the terminal line OF and OD. I'm sure that is clear. Now, if you look at this, this is also as similar as this, as we are moving directly from the x-axis, which is on the terminal axis as x, all the way to c. When we move and we are saying this angle we have here is alpha minus beta, the movement. If this is the alpha minus beta, then the terminal line, we know we are moving from here. This is the angle. The angle is going to be alpha minus beta. So the point C will also have the coordinate of x-axis of the angle, which will be the cos of alpha minus beta, comma. Then the y-axis correspondent will be sine of alpha minus what? Beta. So all this is the point we have. Then if you come to the A point, we know the x coordinate. This is the unit circle, so that will be 1. Then the y coordinate will be 0. So we have 1, 0. I think this will not be difficult to find because this one is just exactly on the line. So that is the unit circle, which we say the radius is 1 unit. All right. Then if we say the two triangles, so I'll be having, let's pick it from this place, triangle A, do I have A here? Let's say DOF is congruent to triangle, let's say from here, AOC. They are congruent, meaning they are almost equal if we want to pick it that way. So if this is congruent to this, then we can say that the line AC is congruent to the line what? df. That means this implies that line AC is congruent to line DF. Right? Good. Then we can find the length. It means that the length of AC will be equals to the length of what? DF. And how do we find the length of a line? From 2 points. We know the length of a line, or a distance formula. Let me just say distance formula is the distance equals to the square root of the x coordinate plus this. But remember this, we don't know the actual position is between 2 points. So x2 minus x1 all square, y2, y1 all square. That is what the distance formula is, meaning the distance between the 2 points AC and the distance between the 2 points DF. Finding it, we can use that. Now, what do we do? Let's begin with that of this. So, if you are finding the distance between DF, so our DF will now be equals to the square root of the difference in the x coordinate. The x coordinate are the first one we are having. So this minus this, the difference. This minus this. So I'll be having cos alpha minus cos beta all square, representing the x subtraction, then plus the y subtraction, which will now be sine alpha minus sine beta all also square. That's the distance between the DF. All right. What do? We can apply the squaring of the bracket in there. Because of space I'm having here, I might be swallowing some of the method. So here, we square the first, twice their product, square the last. So if you square the first term, that will give you the cos square alpha, twice their product, meaning minus 2 cos alpha cos beta, then square the last. So if you square this, remember this is positive, the negative square will be positive. So I'll be having plus cos square beta. At this point, the board is small, so maybe you have to take your time and follow through. So this expansion is only referring to the first bracket. So now plus square the first, which will be the sine square alpha twice their product, sine alpha sine beta plus sine square beta. I know if you're getting it. 1, 2, 3 is from the expansion here. All right. Now what do? We can see in here cos square, cos square, sine square, cos square, sine square. So let's see if we group like terms, this and this will be coming together to become 2 of that, or let's say, since it's positive, I'm seeing cos square alpha, then sine square alpha will become 1 from the identity. Then cos square beta, sine square beta will also become 1. I mentioned because of space, I will be swallowing some of the methods. So this means that the root I'll be left with will be this, and this is 1. This and this is also 1. Then I should be left with only this and what? This, which is minus 2 cos alpha cos beta in the case of this, then minus 2 sine alpha, then sine beta in there. This will be 2, right? So 2 here, 2 here, 2 here. Let's divide through I know you don't like the swallowing of the method, but the board is not that large. So what do we do? This is going to be 2. Okay, let me write a 2 minus 2 cos alpha cos beta 2 sine alpha sine what? Beta. So now we divide through by the 2. Then we can have the root of 1 here minus the cos of alpha cos of beta. This becomes the sine alpha sine what? Beta. I'm sure at this point we don't have anything else to do, so we leave this one like that, representing the length of what? DF. So we need to also find the length of what? AC. So length of AC will also be following the same approach, which is we need to look at this minus this. Do you get that? And this minus this, all square, as we are picking from here. So picking the first one should be the cos of alpha minus beta, this, minus the first, this is the x1, x2, so minus 1. So let me say this square, I think this is the bracket, right? Then we need to pick this one minus this, which is plus the sine of alpha minus beta, alpha minus beta, then minus 0. So all this also what? Square. All right, this is where we need to expand this. This is the square of this. Remember, this is just representing the angle. So the square will come to the cos. If you square 1, it will be 1, twice their product. So let's see how we can do that. We will not get enough space, but let's see. I'm sure you make a copy of this diagram because I'll be cleaning it in order to get a space to transfer these ones to. Okay, but let's still see if we can manage the space here and have the root of the first factor. We are squaring the first term, so square the first, meaning cos square alpha alpha minus beta. This is a square, twice their product. So 2 times this will give you 2 cos alpha minus beta, right? 2 times this is still 2. So then you square the last, plus 1, this plus 1, then plus square the first. If you square the first, it will be sine square alpha minus beta, twice their product. 0 times this will be 0, then square the last will be 0. So it means that this gives us this value. So our AC will be in the root. Where are we going? Look at this. This is cos square alpha minus beta, sine square alpha minus beta. And it doesn't matter whether we are having alpha minus beta, it is still an angle that they are carrying. And that angle is, let's say we are saying this is theta, cos square theta plus sine square theta. That will give us 1. So I am going to replace this and this with what? 1. So that is my 1. Then I should be left with, okay, plus that 1, then minus 2 cos alpha minus what? Beta. Very simplified, right? Okay, I think that will be, let's further move to 1 plus this will be 2 minus 2 the cos of alpha minus beta. I think I can divide further by 2 to have 1 minus cos alpha minus what? Beta. But remember, we are saying that the length of AC is congruent to the length of DF. So we can find the equality of the length, which means that the length of DC equals to the length of AC. So here I am going to repeat the root of 1 minus the cos of alpha minus beta is equals to the root of, will I get the space for that? We are ending here, right? This is 1 in the case of this, minus, this will be cos alpha cos beta minus this minus. That will give us sine alpha sine what? Beta. So here we square both sides. So when you square both sides, the square root will be eliminating. So we should be left with the left equals what? The right. And I'm sure you make a copy of this because I'll be cleaning it so that we know do we need it at the end. Okay, when we need it, I think you refer when we get it. So from here, let's transfer. We square both sides already, so we are having 1 minus the cos of alpha minus beta equals to 1 here minus cos alpha cos beta minus, then we have our sine alpha from here, then sine beta. You can see how we are struggling. If you are touched, you can donate a board that is longer than this so that you just be shifting it, not cleaning all the beginning processes. All right. So if this 1 comes to the left, it becomes 1 minus 1. That will be 0. So I should be left with this alone. Then this will also be negatives. So if I subtract that, I can divide through by negative 1. You understand? If I divide through by negative 1, this is going to be negative, negative. When a negative comes, it becomes what? Positive. I told you I am swallowing some method. I should be writing all this, but space and the size of the video also. So if you do that, you should be left with the, let's say, divide by negative 1. Okay, so this gives me cos alpha minus beta equals to cos alpha, then cos beta plus sine alpha sine beta. So this is what we call the difference formula for the cos. So if you have two angles, that is cos alpha minus beta, the expansion or the formula is to use when you have an angle that are different, then it means the cos of the first angle times the cos of the second angle plus, here is minus, but you're using plus, the sine of the angle, the first one, then that of what? The second one. This is defining the difference. Then how about the sum? We can also say that for the sum, what do we do? We can say this is negative, negative. If I put negative, negative, that will be plus, right? So I can rewrite this as, let's say, cos alpha plus beta should be equals to, let's see, cos alpha minus negative beta. Can that work? This plus here, negative, negative become what? Positive. So I can say that cos alpha minus cos negative negative beta. This is defining this just the way it is. So it means that to find this, I am going to use this. Look at it. The first angle minus second angle. First angle minus second angle. Meaning that the first angle is cos of alpha multiplying the cos of the second angle, which is negative beta, plus the sine of the first angle times the sine of the second angle, which is negative beta. So in the case of this, remember, for the negative angles, cos negative b is the same as what? Cos b as positive from the previous episode that we did. So this will still remain the cos of alpha, the cos of beta. Then the sine of a negative beta is equal to negative sine beta. So the negative will shift in front of this. We need to multiply all of them to give you negative sine alpha and sine beta. And this also gives us that of the sum. Remember, we are picking this is equal to this. This is equal to this. Because we know this, we use it to find this. So when you have the cos alpha in the sum, here become negative. That is all. So this is only showing the sum and difference of cosine. Now at this point, the video is about 20 minutes. I'm tempted to end this one here. In the next episode, we pick that of the sine and the tan. I think that will make it a lot easier. If I continue that direction, the video may get to 30 minutes. So I think you'll come back to episode number 26 for us to derive the formula for the sum and difference of the sine, the function sine, and the function what? Tan. Thanks for watching. If you find this video educative, don't forget to share with whoever you think may need this. If you are touched, to give us anything, as the board, camera, anything, so that we can make this work well for living. Bye bye.